retaining structures, elements of earthquake engineering, bridge engineering, coastal engineering, NDT, and other related things. So related to the materials also. So we do offer it. So currently, as we identified, we provide them the strong foundations for the fundamentals of structural analysis and the mechanics, engineering mechanics, and we expose them to the design concepts of reinforced concrete and steel structures, and even the pre-stress materials. And we make them to familiar with the analysis tools for determinate as indeterminate structures. So we have a conceptual as well as the numerical applications, and we use the digital modeling techniques using that STAT and ETABS. So we have even open building design softwares. So where we have an hands-on to get a better idea of their analysis, conceptual analysis with the tools which they are rightly using it. And we have again specialized electives. This electives offered only for minor, the students who opt for minor specialization in structural engineering. So not for everyone, only for the students who offer with a minor specialization. So this is an overview of our academics. So now we just have, we have another colleague we wanted.
In addition to this, we have internship. Usually at the end of fourth semester, students go for industry for 2-month internship initially. Then in the 8th semester, we have a 6-month internship. Totally before completing, they will be before completing the degree, they will be undergoing totally 8 months of internship totally in the industry. Yeah, in the UG I'm talking about. For MTech it is different. So 1 year theory classes here, then 1 year full internship for the MTech students.
Sir, for MTech students, we have advanced topics on structural analysis, advanced topics on design of reinforced concrete structures, and elements of earthquake engineering, structural dynamics, finite element method. And we do have also the professional practice labs. We call the expertise from the area, and we will sensitize the students regarding the current trends and the practices industry, and get them that industry exposure to that. So that's for the MTech students. Whatever I presented here is for purely for the BTech students. So MTech, additional to that, the advanced topics they're going to study on this. Yes, sir. As we have a little query regarding that, so I think sir will take up a few questions and then we will discuss on that.
Yeah. Good afternoon, everyone. My first question is, what do you currently expect from a fresh structural engineering graduate entering your organization?
The candidate entering our organization, we expect him to be
as a structural engineer.
as a structural engineer. Should be strong in fundamentals. He should be able to understand the behavior of structures, fundamental. Because many of the time that focus is not there. They just do some modeling in STAT or ETABS, but the modeling is not correct. And they don't even check back whether the model is appropriately modeled. So fundamentally how it should behave, whether it should deflect in a certain pattern, elemental things, no. Such things are, we find many times it's missing.
When you say as a structural engineer, I presume that this candidate is a postgraduate student. Yeah, in that case, but mostly they would be confined to logics of modeling. If they are undergraduates, they may not be in a position to analyze the structure as a professional. They might run the analysis and give me the result. But structure is not, I will provide the strength that the structure demands. I always believe if I am an engineer, I should say the structure should behave in the way I want it to behave. That is very important. Otherwise there is nothing. And there are few things that undergrad modeling, very precise. Very often when I see people modeling in STAT, I always see somewhere one column is modeled in the reverse direction. Suddenly the structure behaves in a, and we do not even look into the end result. The deflection pattern itself, when you run it, we will know. Huh? We will know that there is something wrong. And that is especially normally what I've seen is all the columns are top to bottom to top. Suddenly one is drawn top to bottom. That is totally reversing. See, this is a very fundamental thing of structural engineering: Y direction, definition, and modeling it. These are few things that we will check normally. That is what we will look at, and understanding the structure as a whole. It is not, especially in undergraduates, I always feel, because when we are in the curriculum, we will teach them how to design a beam, how to design a column for various conditions, how to design a footing, that's it. But do they know how load is transferred from the slab to the beam and then to the column? What kind of loading creates a torsion in my beam?
I strongly feel that undergraduate students must thorough with reading of architectural drawing first, especially the level differences, where they fail to understand what actually building is when there is a uneven levels or multi-levels, and even the loading pattern, dead loads, and the cutouts, openings. Unless they study the architectural drawing and the sections, nobody can do the modeling. I think that is the main thing, to study and understand the drawings that is given by the architect.
Yeah, in my opinion, structural engineer, when he is entering into the industry or a company, he should see, apart from the structural analysis and the stability of the structure, he should see the external influence or from the other component of the building. One is, I will tell you, external transport, the vertical transport, the elevator. And second one is, if at all I am taking from the electromechanical equipments, like a DG, diesel generator will be implemented, chillers will be implemented, and then the pumps and motors are there. So all these components are active components where they are running, and our structure is a passive component standing out. So what is the behavior actually? If at all there is a impact from the some misalignment of the lift, it will impact the structure directly. And if at all there is a pump, there is no padding given, that noise is transferred to the structure directly. So that is impacting the end user again. So this is a things actually probably gap analysis we need to see. If at all that can be inculcated into the component of learning, and it will help.
Okay, sir. Another thing that we have a lot of our postgraduate students. So, from postgraduate student point of view, so what all that the gap you feel that, so when you do the interviews and other things, which they wanted to learn in their learning experience. Yes.
Let us first discuss the graduate system. So as Nagesh was saying, they are all graduating as civil engineers and not as structural engineers, unless they have taken a minor specialty where they will study a little more of structural engineering. Like for example, they pass out as civil engineers without learning about pre-stressed concrete, which is used everywhere. Somehow that is because you have this many credits and that much of slot to be filled and adjusting, balancing. So whichever teacher is strong, his subject will remain, the other teacher's subject will go. So that may be the physical constraint that you have. But looking at what is expected from the student as a graduate, let's not say structures, but okay, he is, let us say, employed in an organization where there is a lot of structural engineering. So let's take it from that point of view. What is missing today in BTech students, probably even during my time it was missing, is the feel for the structure. Now if something goes wrong, or if something is behaving abnormally, there is nothing that tells him, hey, something is wrong here. That has not gone in at all. Like for example, if he is sitting in a hall like this, for this particular span, what could be the approximate size of the beam? How that beam would have been supported? What do you mean by a rigid support? How do you ensure a rigid support? Or there are now lot of convenient ways of switching on the bending moment, switching off the bending moment, without realizing how it is actually built. Just because it's convenient to switch off the forces, it doesn't behave that way. It has a unique behavior. How well you understand and respond makes you a good engineer or otherwise. So from that point of view, as he rightly mentioned, right from architectural drawings to civil engineering drawings to MEP drawings and electrical drawings, that student is expected to know whether he goes to the field or sits in the design office. Either way, he is expected to know how to read a drawing and how to detail the reinforcement. Today, in the curriculum, there is no specific mention of how detailing is to be incorporated in his mind. I'm not saying that it may be there in one corner of a syllabus, but the teacher has to make sure that if he is to be useful from day one, he should know this. Then coming to postgraduate, many a times people have, of course I was in teaching, so I know what happens. So they are saying, yes, 8 semesters of study gives you a BTech, another 3.5 semesters gives you a MTech. So nothing better than any UG. He has only studied 1 or 2 more subjects extra, and some of them are repeat subjects, some of them are just there. So now how to make him an expert structural engineer depends on how well he understands the behavior, right from, as he correctly mentioned, load path onwards, and implications of removing certain things. Suppose a Vastu fellow comes and says, remove this column for me. Now, what is the implication of that? People blindly do it. Similarly, the concept of floating column, the concept of concealed beams. Just because you assume that it is a beam, you expect the load to go carry through that because you put a board there. Please go this way. So these are things which has to be inculcated in the students, that this shall not be done. Of course, the code permits you to put floating columns, but he says don't use this for seismic resistance. But people don't know. So this modeling itself, depending on how much of inputs he gives, whether he is giving the rightful inputs and whether the output is making sense. Although post-processor visual is there, he is not able to make out. 100-ton meter or 1,000-ton meter, he will calmly come and say that this is what the computer gave. So we have to somehow try to make him feel the structure. Not easier said than done, I fully agree. But certain small gaps are there, but that's probably because of the constraints of accommodating the subjects. So pre-stress concrete, please do include somehow, if not full subject, but at least something as a part of RCC, so that so that the student knows that there is also.
Sir, as you said, because of this flexible electives, minor electives, those.
I fully understand.
Yeah,
I have done that for 22 years, so I know what it is.
Now, sir, as you said, pre-stress concrete, actually, it comes under a structural strain. Now what we did is, we removed that flexible core concept. We kept only minor, because we have introduced pre-stress concrete as a core now. So in
okay, but then your syllabus was flashed earlier.
1 minute, sir.
In that, flexible was there.
Yes. In the new syllabus, for the present batch, we have modified it.
Okay, that you should have told us.
Yeah, correct, sir. We have introduced pre-stress concrete in the new syllabus as a core subject, sir.
But now it is 160 credits, or total your undergraduate is 160 credits?
Yeah, 160.
That remains 160,
Yeah,
168. Yeah.
Sir, it's not like that. Flexural core, no? So it's either structure stream, environmental stream, or construction stream.
No, that's okay. That's okay.
So now it's the flexural concept itself is removed. The flexible concept itself is removed. So we have fixed the subjects there, but minor concept is there. Either minor in structures.
That is extra credits. He studies 8 credits extra, no?
No, it's in 160 only.
Oh, within 160.
Within 160 only. It comes under minor. So he will be civil engineer with minor in structural engineering. provided he completes a project in that particular field, mini project.
Okay. What is the evaluation mechanism for projects? That also is a very important
Yeah.
thing, depends on that. His seriousness on the project depends on
That's true, sir.
the method of evaluation.
Yes.
So can you just tell us how do you evaluate?
Actually, that project starts in the seventh semester itself. Seventh semester beginning it starts. So at the end of seventh semester, they need to submit it. I think there will be a guide will be allotted for them. So guide will
In
be
addition to the chat GPT.
No, we have AI also, AI detection tools also.
Okay, you detect, it's okay. But what do you do at the end of the semester? He has already submitted, he is about to go. You can't ask him to do a project for 6 more
No,
months.
no. It will be in the end of seventh semester itself, sir.
Okay.
Seventh
So
semester.
in
Each
the-
semester project is different, sir. Each semester project is an internship.
My intention is to
That's
say
true.
that evaluation
Should be.
and the rigor of evaluation is very important.
Correct. Thank you.
I would say that when you are giving them a minor stream as a specialization, why not make them work for this mini project under a professional other than their teacher? There are plenty available. Yeah, jointly, yes. Jointly,
Yeah, yeah,
yes.
of course.
And the project shall be defined by the person who is in the field. Thereby, you are going to make the student exposed to what really a professional life means.
That's true, sir. But here, along with that project, they will be attending the classes.
Sir, these days I am guiding the 2 PhDs and 7 MTech projects across India. Everything happens Google Meet, sir.
That's true. That's true. We'll think about it, sir. That evaluation, the mini projects.
Yeah.
Regarding this postgraduate, okay, naturally the expectations will be higher compared to the UG. And normally we are taking them into our design. The weakness we have seen over the years, either in steel, concrete I think people are fairly familiar, but in steel I think especially the stability and other issues, no, they are not at all clear. Short drawing reading is a different aspect. I'm just talking about the analytical way. There is one weakness I could find: connections, the importance of connections, bracing system. These are the areas they are not that weak. Another area is on dynamics. And when you are to do a machine foundation or something, the concept itself is little vague for them. So our expectation is that they might have done something on structural dynamics.
Sir, we have structural dynamics in the MTech.
Yeah, I'm talking
We
about
teach,
postgraduate.
and we have recently procured.
Software.
No, not software. Vibration lab.
Okay.
We have already created.
That's good.
It's already there. It's in the first floor of this building. Just to demonstrate the
Okay.
vibration.
Another area is on this FEM. Finite element analysis, meshing and interpretation of the result is a little vague area, they are not strong. So I thought these areas we should be able to take up, will be better.
Very important, sir, as Kalkan said, that detailing should be embedded into the student's mind.
Correct.
Whether he learns it or gradually picks up the skill,
Correct.
it is secondary.
Correct.
But he should know the seriousness of detailing.
Detailing.
In RCC and shop drawing in case of steel.
Correct, sir.
Those two should be, people should know, that is a very serious thing I should know.
That's true.
If I am to be a professional in structural engineering.
That's true.
And one more. Right now you have a code for tall structures, right? Now that is only for concrete at this point of time. The next version is coming probably few months, which is for composite sections. So you better start now in the syllabus the analysis and design of composite structure, steel, concrete, composite structure. You better start building, because by the time they pass out, it would be already 3 years old, that code. So please include composite structures as a part of your syllabus. And what about rehabilitation engineering?
It is there in the syllabus, but as an elective.
Okay. Where, in the BE or in ME? MTech. Okay.
I think even in undergraduate, they should start introducing the topic, sir.
Because along with your sustainability, you better also add rehabilitation.
Sir, then regarding the software skills, the software.
There is no end to the softwares. As Reyes was mentioning, at least one fundamental software he should be aware. Allied, he can be aware depending on his time and certifications that are available online, offline, because everything can't be crammed into the syllabus. That's just not possible. So have one primarily used management software, one structural software as a core or as a part. Rest of it is all depending on his interest and his marketability. If he has more, he will market himself better. So that you have to drive into the students.
At master's level, I prefer that one generic FEM package they should be able to handle. All these ready-to-use software, StatPro, I admire that. I use it very often, or ETABS, or everything. But generic FEM, they should learn. Thereby, they will know the skill of modeling, and fine-tuning their model comes in the generic FEM.
Any questions from the students?
Yeah, we have
One question, sir.
Yeah, hello, good evening everyone. Yeah, I just wanted to ask, resume is the form we present ourselves and the companies can also shortlist. So I wanted to ask what kind of projects should we work on so that the our resume is highlighted among all of the others.
Roam around this city, see what kind of buildings are being built, what is the system there, make projects out of it. That is what the industry or commercially what is selling. If the builder can sell a particular building built in some time, some type, that is where you lie. Your project reflects that, your resume is automatically highlighted by the AI. Look at problems from the industry. Talk to the consultants, local consultants, go to Mangalore, you talk to people, sir, what are you designing, what type of building? And when you are writing the resume, title your project work right. Don't make it too generic.
Yeah, any other questions?
You can, 1 minute, you can always think of the present market trends in high-rise residential building. But what we seen in the local area for the last 15 years is industries. Each industry is specific and each industry is different, but there is a challenge also to understand the machines and the machine loading, and you need to learn a lot, and you have very less competitors in that field, to be frankly telling. So you can always think of that specialization in industry designing, which is coming up in a larger scale in our area, especially in Mangalore, Udupi and Nagpur.
Tan your skin 2 grades higher, automatically you get hundreds of projects. Yes. You understood? Your skin should go 2 tones ahead.